When you multiply two matrices, unlike adding or subtracting, there's very different rules that apply. When you add or subtract matrices, you just have to make sure they're the same dimensions. When you multiply two matrices, that's not the case. Although having two of the same dimensions would be okay, there's more to it than that, and I'm going to show you in this video. So the question at first, before I actually get to doing the multiplication, and we're going to use the calculator to do the multiplication, they're going to ask us, is AB defined? Meaning, if we were to multiply matrix A times matrix B, would it be defined? Meaning, would there be an answer to it? And then if so, what would the dimensions be? We'll get to that in a second. So here's how it works. Let's take these two matrices, matrix A and matrix B. I have no idea what's in those matrices, but to tell whether it's defined, it doesn't matter what's in it. Here's what I want you to do. Write your two dimensions side by side, and make sure you put them in order, because that's going to be important, as you're going to see in a second. So a 3 by 4 matrix multiplied by a 3 by 2 matrix. So remember, that's rows first, so it's a 4-row matrix and a 3-column matrix, and then a 3-row matrix and a 2-column matrix. So we know that we would not be able to add these, they're not the same size, but it turns out that we actually can multiply them together. What needs to be true is that these two inner dimensions need to match up. They need to be the same number. In other words, the columns of matrix A needs to match up to the rows of matrix B. And as long as that's the case, you can go ahead and perform the operation. So yes, matrix, or if we multiply matrix A times matrix B, it would be defined for this example. They ask us what the dimensions of the answers would be, and it turns out that those leftover numbers, the 4 and the 2, would be the dimensions of my answer. So the answer would be a 4 by 2 matrix. And it's kind of interesting. We have two completely different size matrices, a 4 by 3 and a 3 by 2. We are allowed to multiply them together, and our answer is still a different dimension altogether. It's a 4 by 2. So multiplying is much more complicated than adding or subtracting. Now I had said be careful that you do this in the right order, because watch what would happen. Suppose I put the dimensions of matrix B down first, so a 3 by 2. And then a 4 by 3. Well, the rule is that these inner two numbers need to match up, and if I switch the order, it doesn't. So again, matrix multiplication is very, very different. We're used to multiplication not mattering. You know, you can flip the order of numbers, and who cares what order you multiply numbers in. But matrices, it does matter. It works one way, but it does not work the other way. So just be careful about that. But that was just a little side note. Anyway, back to our second example. Is A times B defined? So to figure that, again, I like to write my dimensions side by side. So it's a 3 by 4 multiplied by a 3 by 2 matrix, and in order for the multiplication to work, in other words to be defined, those inner two numbers need to match up. In this case they don't, so we cannot do the multiplication. It will not work. Once I show you how to do this in the calculator, you could try typing a 3 by 4 and a 3 by 2. It'll give you an error message. You're not going to be able to multiply those together. So let's go ahead and actually take a look at how that process is going to work. So I have this slide where we've multiplied matrix A times matrix B. I've given you two matrices to start with, and I guess the first thing that we should do is make sure the multiplication would work. These are both 2 by 2 matrices, so it's a 2 by 2 and another 2 by 2, and I told you that these inner two numbers need to match up, and this time they do, so the multiplication will work out. And then my answer matrix will be the size of those leftover numbers, so my answer will be another 2 by 2. So kind of like adding or subtracting in this case, everything stays the same dimension. Now I'm not going to go through too much detail about how this works by hand, because I just want to use in my calculator, but what we're doing is we're multiplying an entire row, this 1 by 4 row, by this first column, the 5 by 9 column, and I've kind of written down my work down here. So that entire row I've started with 1 times 5. I'm going to add that to 4 times 9, and I kind of have to, I don't really want to do this by hand. So since the calculator will always be able to do this faster and more accurately than we ever can, let's go ahead and use the calculator to actually do this multiplication. Let's not be too concerned about where these numbers all came from. I don't really care. I just want you to be able to do the multiplication at this point. So let's switch over and do that, and then we'll answer an interesting question too. Is matrix multiplication commutative? In other words, can I flip the order? And I kind of already showed you in that last example what could go wrong, but we'll use the calculator and see that even though the order wouldn't, or the multiplication will work in any order, you'll see that we may not be getting the same answer if we do that. So let's break from doing this by hand. Let's switch over to our graphing calculator and let that do this multiplication for us. So we've taken a look at how to determine whether or not we're allowed to multiply two matrices together by checking their dimensions, but we're going to go ahead and use the graphing calculator to actually do the multiplication, because as we talked about, multiplying an entire row by an entire column and going through this process is kind of time consuming, and the calculator is going to be much quicker and sometimes more accurate than we can be. So here's how it's going to work. Let's go ahead and multiply these two matrices using our calculator. So if you recall, the matrix button is located right here. It's second, and then hit the inverse key, that's the x-1 key, to get this menu to pop up. To actually enter in the matrix, go into Edit, and then choose your matrices. Let's just go ahead and use A and B, so select matrix A. They're going to ask you for the dimensions. These are both 2 by 2 matrices. It's 2 rows by 2 columns, so go ahead and get those typed in. I've gone ahead and already typed in my elements to save some time. If you need to pause the video to type in your elements, then go ahead and do that. Once that's typed in, you need to quit and go back to matrix to do matrix B. So repeat the process, matrix. This time go to Edit and select matrix B, or whichever two you want to do, but I'm just going to stick with A and B. Again, I've already typed my elements and dimensions in. If you need to pause the video, go ahead and do that. But it's a 2 by 2 matrix, 2 rows by 2 columns, and then there's my matrix information. So once that's done, quit. And once you're in the home screen, the main screen where you would normally do calculations, that's where we're going to do this. So back into matrix. This time we want to select from the names menu. So select matrix A from the names menu. We want to multiply that, and you could do this for addition like I mentioned, although this is really time consuming just to add some 2 matrices, which is very easy to do by hand. And then select matrix B and press enter, and voila, there is our answer matrix. You can see it down here. If you were to go ahead and do this by hand by adding these all up and continue to multiply rows by columns, you'd see where that came from. But notice it's not just as simple as addition, where it's multiply the first element by the first element over here. 1 times 5 is definitely not 41. Now we've talked about whether or not the order matters, and we've hinted at that it definitely does matter. It's not like multiplication of numbers where if I type in 5 times 9, that's 45. If I type in 9 times 5, that's of course also 45. Matrix multiplication may not work the same way. So let's go ahead and actually test it, and let's test whether or not it's commutative. So flip the order, go back and type in matrix B first, times matrix A. And we know the multiplication will work because they're both 2 by 2 matrices, but will we get the same answer as the 41, 17, -3, -33 answer? And we see that no, absolutely we do not get the same answer. So to answer the question, is it commutative? It definitely is not commutative. The order matters. So be very careful when you type these in. Make sure you're doing these in the correct order, but feel free to use your graphing calculator, especially as the matrices get to be bigger dimensions. It's a very time-consuming process to do by hand, so let's let the calculator do that stuff for us.